Okay, so this is going to be in the entire chapter that we just did. Um, let's start with the most basics, and then we can go from there. What we talked about are triangles. Talk about the properties of the triangle, property of the exterior angle, and then we can go from there. What we know about triangles is it has three interior angles. These three interior angles add up to 183. So, all three interior angles add up to 180 degrees. Now, the idea behind this is that if I give you two of the angles, you should be able to find the third one by subtracting those numbers from 180. For example, if I had a triangle, I said find x. Okay. You know this is 76, you know this is 62. To find the third angle x, you would have to take 180 minus 62 minus 76. Now, if you did that, you would end up with 42 as your answer. So that's the basics of what a triangle is. Now, every triangle also has something known as an exterior angle. What an exterior angle is just an angle that goes off one of the three angles. The exterior angle could be here, it could be here, or it could be here, but for simplicity reasons I'm just going to put it right here. Okay, so there's an exterior angle. We know some properties about an exterior angle. So first I'm going to put EX, which is going to stand for exterior angle. Okay, and then we're going to have the first angle, the second angle, and the third angle right here. So 1, 2, 3, those three angles. Now there's something we know about exterior angles. If you take the exterior angle and you add the one right next to it, so these two angles right here, you should get 180. That's what you should get. If you take angle 1 and you add angle 2 to it, you should get the exterior angle. Okay. The reason why is if these two add up to 180, and this whole thing adds up to 180, if you think of it like this, the exterior angle is 1 plus 2, so we could actually take this exterior angle, replace it with 1 plus 2, we'd get 1 plus 2 plus 3, and since we know all triangles add up to 180, you can see that that's 180. So, we know this works. So, if you're given something like, let's say you get a triangle with an exterior angle. Alright, let's say you have 2x plus 10 here. 2x plus 10 there. You have 30 right here, and then you have 4x plus 12. Okay. To find the value of x, you know that this equals this plus this. So you'd have something like 4x plus 12 plus this 30 here equals 2x plus 10. Okay? So you have this concept. What you first have to do is combine like terms. Now, like terms, as you know, are anything that has the same back end. So this is 12, it has nothing in the back. This is 30, it has nothing in the back. The 4 has an x, the 2 has an x, the 10 has nothing. We can't go through an equal sign, so we can only combine things that are on the same side to start with. Well, 12 and 30 are on the same side. They have nothing in the back, so therefore they're like terms, so they can be added together. 4x cannot be because it has an x. These don't have x's. Because they don't have x's, they don't combine with the 4. So it just becomes 4x plus 42 equals 2x plus 10. Now, the next step is you have to label which side are you going to bring everything onto. Okay, so I'm going to bring all the x's over here. I'm going to bring all the regular numbers over here. So first let's look at what's in the x. I call this the x house. So if you have two people living in the x house, 4x, so 4x and 42, who doesn't belong there? Well, 4x belongs there because it's the x house, so we have to get rid of the 42. So you always subtract the 42. And then you have to subtract the 42 on this side, but we do it from the 10 because once again, this doesn't have an x and this doesn't have an x. So that's the two things we have to subtract from. This becomes 4x equals 2x minus 32. Then you would solve. Then you get rid of 2x out of the number house because 2x doesn't belong in the number house. So you have to subtract 2x, subtract 2x. Now when you subtract x's, you just subtract the coefficient or the numbers in front. So that becomes 4 minus 2, which becomes 2x equals negative 32. Now, everyone's home. They're in their right houses, so we can get rid of the number in front of the x. How do we do that? Well, this means multiplication. So we're going to do the opposite multiplication, divide by 2. Divide by 2, x will give you negative 16. Okay, so that's interior angles, that's exterior angles. Now let's go with two special triangles. You have two special triangles. One is called an isosceles triangle. It's called an isosceles. The other one is called an equilateral. Okay. So there's special properties for each of these. With an isosceles, so these little tick marks on the side of the triangle, what that means is that they're congruent. What congruent means is that they are the same measure. They're not the same object, meaning obviously they're not the same side, but they have the same measurements. So if I said this was 17, then this would also have to be 17. If I said this was 3x plus 10, this would also be 3x plus 10. But there's something special about this that we need to know about. That the opposite angles, the angles opposite to these tick marks, so opposite means that here's this side, so it'd be this angle, is congruent from this side and this angle. So once again, these are also congruent. So this is congruent to this is congruent to this. Now we know something special about congruent things. That if they're congruent, they can be set equal to each other because their measurements are equal. So if this is 3x plus 10, let's say this side was 40. Okay, so ignore the 17. Now, obviously, they're not both 3x plus 10. But we know they're equal measure, so this is what we can do with it. We can say 3x plus 10 equals 40. Because they're congruent, anything that's congruent can be set equal to each other. They don't have to look the same right away, but these technically are the same because when we solve for this x, whatever x is, it should make this side 40. So we'd solve for this and we'd get whatever the thing is. With an equilateral triangle, we know all three angles are equal. Okay? And we know all three sides are equal. So, this, like the isosceles triangle, if I give you two sides, you should be able to set them equal to each other. If I give you one of these angles, you should automatically know that they're all 60 degrees because they can't be anything else since they all have to add up to 180 and they all have to be equal. Therefore, all of these will have to be equal like so. So that's all the different types of triangles we have. Now, there's ways to tell if two triangles are congruent based only on markings. Okay, so you have three different ones. First one is side, side, side. Okay, if you have two triangles, let's say these two triangles right here, they don't always have to be connected. I just like connecting them because we're going to connect them later on. But you have these two triangles. If they have one side, okay, two sides, and the third side congruent to each other, then they are congruent. Now there's a reason why I wrote 3 tick marks versus just one. So 1 means that this is congruent to this. 2 means that this is congruent to this. 3 means this is congruent to this. But since it's 3, this is not congruent to this, it's not congruent to this or this. It's only congruent to the one that it matches, the number of sides. Not all triangles need to look like this. It could even look like this. It could be like that. This still is side, side, side. These two triangles are congruent because they have 3 sides that are congruent. So that's what side, side, side means. Let's say if you have two angles, okay, so if you have two angles, now let's do side, angle, side, okay. So this one means that you have a side, an angle in between them, and then a second side. Okay, so this means side, angle, side. The angle has to be in between these two things. If it's over here, it doesn't count. If it's over here, it doesn't count. It has to be in between the two sides for it to be side, angle, side. If you see these markings in any way, if you see side, angle, side, then it should be congruent by side, angle, side. The next one is angle, angle, side. Okay, angle, angle, side. So let's say this is congruent to this. Let's say this angle is congruent to this angle. And then we say this third side is congruent to this other side. Okay. So, how I tell everyone to start is that you always want to look for something. Like if we saw this triangle, like separate these two triangles, if you saw this triangle as a lone person, if you see nothing to the right, so there's no angle or side to the right, and only one thing to the left, then we can start with this. Or we could start with this. Nothing to the right, something to the left, okay? So it doesn't always have to be like that. But it just needs to have like nothing, no extra side or angle. That way that start with that. So this is technically side, angle, angle, which is just this spelled backwards, which it doesn't really matter. So it just needs to be angle, angle, side. Okay, so angle, angle, side. It's not to be confused with angle, side, angle. So let's compare these two. So I had this. So this is not to be confused, because if you see here, you have two angles with a side in between. Here, the two angles does not have the side in between. These both prove that triangles are congruent, but they are different postulates or theorems or whatever you want to call them. So you have angle, angle, side, angle, side, angle, so on and so forth. Now there's two that we cannot have. If you have three angles, or you have a bad word spelled backwards, if you have ASS or SSA, if you have either of these, they don't work. We put not enough information, or NEI for short. What this means is we don't have enough information yet to prove those two triangles are congruent, therefore they aren't congruent. Or actually we don't know they're congruent yet, I should say. So these are to help you with that. So let me explain different parts that we have on the test and stuff like that. When you have something like this, okay, when you have something like this, we know something is congruent right away. We know what are known as vertical angles. Okay, vertical angles it's a deceiving name. It doesn't mean that angles that are on top of each other. It just means angles that are created by two straight lines. We know they're automatically congruent. So we could have it look like that. And this also works. So this is congruent to this in this way. Okay. You can mark these whenever you want, because these are always going to be congruent. For example, if I had this thing marked and this thing marked, this thing marked and this thing marked, and I didn't have these angles here, I would draw the angles in. Okay, I would say, okay, so I know these are also congruent. Therefore, I know that these two triangles are congruent by side, angle, side. Okay? You'll have that, or you'll have something like this. Okay? So what these two have is they have a common side. You have two triangles here, 1, 2, 1, 2. Okay? They have a common side in between them. We can just mark it congruent to itself. What that means is that if I took these two triangles and I separated them, they would be two separate triangles. Because they had the same line here, that would be the same length, and we would know that's the same length because they share that side. So we can say that that is like itself, okay? So we can have, let's say we had this. Okay? We would mark the middle thing, and now we would know that these two triangles are congruent by angle, side, angle. So angle, side, angle. Or this one's the same idea. You can do that, mark the common side. So you should always be able to mark the common side. Last but not least, congruency statements. If you have something like ABC is congruent to triangle ABC is congruent to triangle XYZ, you have some special ideas. You have to go in letter order. That means that A is congruent to X, B is congruent to Z, and C is congruent to Z. So if I asked you what part in triangle XYZ is, let's say, CB. Line segment CB, what is it congruent to? Well, we have to look over here. C is in the third position, and then B is in the second position. So you go 3, 2. So we have to go over here. What's in the third position? Well, Z is. So we know Z is in the third position. We know Y is in the second position. Therefore, it would be ZY. YZ is not correct, because it needs to be in the same order and in the same position. So second first, so it'd be, third second, so it'd be third second. So if I said angle B, it would be congruent to angle Y. Now, sometimes two triangles are congruent. For example, if you have, are connected. Let's say we had A, B, C, D, E. And I told you that triangle ABC is congruent to triangle EDC. So those two things are congruent. Or not EDC. Yeah, EDC. I said those two things are congruent, and I wanted you to tell me these two angles are congruent. I want you to write it down that they are congruent. Okay, so these angles cannot be just named by one letter because the fact that there's two C's. So we have to name the angle by using the side letters to help us. The C always goes in the middle because it's what's known as a vertex. It's where the two lines meet. So this is the vertex of ACB. So we'd say angle ACB is congruent to, so ACB would have to be ECD. If I gave you something like that, that's how you'd have to write that in order for it to be correct. So let's get to the proofs. Okay. So let's look at this. Okay. A, B, C, and D. Okay. So A, B, C, and D. So we have these two triangles. So if you're given means this is information that is free. It's information that you don't have to prove to be true. You just know it's true because I told you that it's true. So I tell you that angle A is congruent to angle D. And I tell you that BC, that angle ABD is bisected by BC. That's the given. I'm going to tell you to prove triangle ABC is congruent to triangle DBC. So I'm going to tell you, ask you to prove that to me. So first we know A is congruent to D. Okay, so that's something that's given to us. So we're going to write we know statements. We know. What do we know? We know angle A is congruent to angle D. Why do we know this? As I said before, what is the given? The given is information that is given to you. You don't have to prove it. Therefore, we know this because it was given to us. It was given. That's why we know it's congruent. Now, the next part, we don't have anything else that we know is congruent. All we know is that ABD is bisected by BC. So the next thing we have to say is this. Bisected. Bisected means to cut in half. When you cut something in half, it makes two congruent parts. So if I say this thing is bisected by BC, then that would mean that both the halves that it creates would also have to be congruent. So these two angles right here will have to be congruent because it cut this larger angle in half. So we know that ABC, now remember this is an angle, is congruent to DBC. So ABC is congruent to DBC. Why do we know that? Because BC bisected triangle or angle ABD. Now we don't have to go on from there. Why? Because we know what bisected means. It's a mathematical term that means to cut in like half and to create two equal halves. So bisect something in half. Therefore, it's accepted that we can say it's bisected by BC, so therefore these two angles have to be congruent. Last but not least, they share a common side. We know that the common side is the same thing because it's going to be the same line. So we have to make the statement like this. We know that segment BC is congruent to segment BC. Why? Because it is the same line. I mean, it makes sense in math. What's hard about mathematics is that you have to explain yourself. If you don't explain yourself, nothing is assumed. Obviously, it should be obvious that BC is congruent to itself because it's the same object. But we had to make the statement in order for it to be true. So we have three we know statements, and we have three parts. At this point, we can't prove anything else is true. So I have to look at this. Do we have enough information? Well, we have an angle, and a side. Well, if we remember back to this whole thing, angle, side is one of our congruency theorems. So when we go back here, we say, okay, cool. So we know we have enough information. So what do we know? We know they are congruent by angle, side. We know triangle ABC is congruent to triangle DBC by angle, side. And that finishes our proof. Now, these aren't the most proper proofs, but they are basic proofs that I just want the kids to know how to do. Now, there's other parts of proofs that still become confusing. Like, for example, if I told you that something is the midpoint. If something is the midpoint of something else, for example, let's say L, M, N, O, P. Let's say I said N was the midpoint of LP. So LP, N is the midpoint of LP. What that means is it cuts LP in half. Midpoint means in the middle, so it goes right in the middle and creates two separate segments, LN and PN. By the fact of the matter that we know that this is the midpoint, we know that this is congruent to this. But unless it's stated, we don't know that N is the midpoint of M. So therefore, if you mark like this, you're in the wrong. This is not correct, because I never told you that MN is, N is the midpoint of MO. So this is an incorrect assumption to ever make. Unless I tell you it's true, it's not true. But there's one thing we do know by the picture. We know that these two things are vertical angles. Okay, so you should always mark your vertical angles, and you should always state that your vertical angles are congruent. So in a paragraph proof, we would say we know LNM is congruent to PNO. Why? because they are vertical angles. You would say something like LN is congruent to PN because N is the midpoint of LP. We'd make these statements to help us understand how to solve this stuff. So bisected means cut in half. Midpoint is the middle of a segment, meaning that it cuts the segment in half. And vertical angles mean that they are opposite of each other. They are created by two straight lines. Therefore, they are congruent. So, that is the chapter in a nutshell. If you have any questions, let me know, and I can help you.